Hello, everyone, and welcome to the Ag Innovation News Podcast, presented by the Agricultural Utilization Research Institute of Minnesota. I'm Dan Scogin, Director of Government and Industry Relations for AURI. Guests on the Ag Innovation News Podcast will shed light on innovations in value-added agriculture, highlight important voices and work that's being done throughout the Minnesota ag sector, and educate the public about resources and organizations that support Minnesota agriculture. Today, we get a chance to visit with Dr. Luca Zullo, AURI's Senior Director of Science and Technology. Our topic today is going to be anaerobic digestion and its future potential for renewable energy, both on the farm and in the community. But first, let's start with Luca's professional background. Luca Zullo started his career at Shell Research in the Netherlands, where he was involved in designing novel oil and petrochemical processes, focusing on process modeling, control, and integration. He continued this work in Minneapolis for Cray Research and Silicon Graphics, leading the development of some of the world's most extensive process plant simulations. In addition, he led the development of Virtual Plant, a pioneering prototype of a visual simulator for operator training. Later at Cargill, he worked in corporate R&D on novel agricultural commodity transformation processes, emphasizing biofuel development and renewable energy in plant operations. He led a group that developed multiple domestic and international projects in anaerobic digestion, biomass utilization, and carbon intensity reduction. Among them, what at the time was the largest cluster of manure to biogas projects in the United States. After Cargill, he then worked with several early-stage companies, leading or supporting the transition to commercialization from early-stage R&D. Among those, he led the development of a venture for a bioethanol-derived chemicals, resulting in the construction of a world-class production site, which now provides bio-based solvents to the paint and coating industry. Luca holds a degree in chemical engineering from the University of Padova, Italy, and a PhD in chemical engineering from the Imperial College of Science, Technology, and Medicine of London, United Kingdom. In his spare time, he enjoys biking, flying, fishing, and reading history books. Luca Zullo, welcome to the Ag Innovation News Podcast.
Thank you, Dan. I look forward to talk about anaerobic digestion today.
It should be an interesting conversation, I think, for a lot of us. So let's start with some foundational things for our listeners. What is anaerobic digestion, and what makes it a value-added ag product or process?
Well, first of all, anaerobic digestion is actually a natural occurring process, and we really exploit what nature already does in naturally, which is converting when oxygen is lacking any organic material into methane through the biological action of a variety of organisms that live in symbiotically. And as I said, it happens naturally. An example that is very germane to Minnesota, when you are in a shallow lake or a marsh, you will see, for instance, a little bubbling coming up from in the water. Well, that is actually the organic material in the sediments of the lake that is degrading, and what you see is actually methane coming up. And this is where really the value comes from an energy perspective and from also agricultural perspective, because that methane can be harvested for energy. And obviously the process of degrading that organic material can also be harnessed for managing agricultural waste and other feedstock in an environmentally sound fashion.
So, what I hear you saying, Luca, is that anaerobic digestion occurs naturally in the world, but this process is used to capture it and control it and kind of build out your own digestion system. Is that right?
Correct. What we're doing is basically harnessing naturally occurring phenomena to optimizing the desirable outcomes from a point of view of what we want to obtain, which is energy, waste management, and so forth.
Is it a fairly simple process?
It is simple in that it occurs naturally. If you put, a bunch of manure, for instance, in a bag and you seal the bag, most likely after a couple of days, that bag might explode because you make the gas inside. But that is also deceptive because obviously from a point of view of maximizing the value that we obtain for it, we need to build engineered systems around it and managing it. So it's a simple process, but it's also a process that requires some some finesse to maximize the value that we can get out of it.
So then how can we use it for renewable energy? What's the end product look like and how do you capture that?
The end product is methane, and methane is basically the main component of natural gas. And so the difference is that in this case, this methane is being generated by the metabolic activity of bacteria using organic waste. Therefore, is fresh methane. It's not carbon that has been stored underground for millennia or actually millions of years and now released in the atmosphere. So we can use it in a carbon neutral fashion without adding CO2 in the atmosphere that can lead to climate change. And so really that is what makes it attractive. By harnessing anaerobic digestion, we can harvest basically what I would call a renewable natural gas. And so carbon free source of energy that is fully compatible with the existing infrastructure, because once you have a molecule of renewable natural gas, is chemically undistinguishable than a molecule of natural gas that is, say, extracted by fracking. But unlike the latter, the former does not contribute to climate change.
It makes me think that you would get different kinds of quality gas from different feedstocks. And I maybe want to come back to that a little later in the show today and talk a little bit about what goes in and what comes out. But let's talk about the manure part of it right now. Is it something that really any farmer that raises livestock or chickens or hogs can benefit from? Or is it just for really large scale operations?
There is some economy of scale that favor larger versus very small operation, but in principle, medium or even relatively small farms can benefit. Now, the EPA calculated that it would take at least 500 head in a dairy farm to be economically viable. Technically, you can do much smaller, but economically, obviously, you need a certain scale. But 500 head is not small. Obviously, there are some efficiencies, so get larger as you go, but you can start relatively small if you want.
So, what are some of the benefits for those who are considering getting into or involved in anaerobic digestion? What are some of the benefits for those operations? And are there incentives for the egg producers or processors to get more involved with anaerobic digestion?
There are benefits beside energy. In fact, we have seen anaerobic digestion being used also when energy was not necessarily the main motivator. The benefits of anaerobic digestion is that anaerobic digestion is also an environmental management approach. A well-run digester in a farm will handle manure much more efficiently than conventional systems like open lagoons and or manure piles. And one of the big benefits that will bring is the ability to reduce odor. A well-run digester will not smell. You will not hear anything of the smells that associate with large scale of manure being accumulated in places, and creates a stream of residual material that is easily separated from a liquid stream and then can allow you to better handle those residual nutrients, phosphorus and nitrogen, and recycle the water for irrigation. So there are benefits that have been long time recognized.
I want to go back to feedstocks in just a bit, but I do want to thank people for getting a hold or tuning in to the Ag Innovation News podcast presented by the Agricultural Utilization Research Institute of Minnesota. Today we are talking to Dr. Luca Zullo, who is AURI's Senior Director of Science and Technology, and we're talking about all things anaerobic digestion. So we're getting the primer on what anaerobic digestion is all about. Let's jump back to the feedstocks because we've really talked about manure. Is there a lot of difference from cattle to hogs to chicken manure? And then is there other feedstocks, switchgrass, bio-based tree branches? Is there other things that we can use in a digester?
Yes, there are. And today, obviously, energy costs are going up, and so the value of that gas that one produces is higher. But in the last few years, we have seen quite a few benefits associated with the environmental properties of the natural gas, which can be monetized. California has pioneered a program, the low carbon fuel standard, where producers of a biofuel are paid basically a value based on how much their fuel is decarbonized compared to standard fuels. And because the value of those incentives is based on the carbon intensity of the gas, manure derived gas are really good value. Today, Minnesota has launched an innovative program of the Natural Gas Innovation Act, which allows the local use of the gas, and so has made local gas utility very eager to buy gas from biogas producers to reduce the carbon intensity of their system. Lastly, there has always been federal incentives to allow farmers to pay through either loan guarantees or grants the cost of developing these projects. And today, those are even better, given the fact that biogas is very central to various programs and the Inflation Reduction Act of 2022.
We talked quite a bit about the manure, but is there other things that we can use in a digester that still produces a pretty good gas?
Yes, almost any organic material can be used as a feedstock for digester, but they will behave differently in the digester, hence the engineering of the digester can change depending on the feedstock. And also they will have different yield. So some material will generate more biogas per unit of feedstock than other. In fact, in that respect, there are some type of feedstock like food waste that actually can provide much more biogas production than manure. Some other material are a very large potential to generate biogas, but they're more complex to handle. They might require some pretreatment, they require specially engineered digesters, so we're only at the beginning of using them efficiently. An example for that would be the organic fraction of municipal solid waste. So each digester has to be optimized around their optimal mix of feedstock, individual feedstock or multiple feedstock, and has to be operated and designed for that. And that is where the harnessing part of this natural process become important. And sometimes you can't use a digester designed for, say, for poultry litter, which is very rich in solids, for something more liquid like dairy manure. But that is where an area where I think we, as an organization, AURI, can help people interested in harnessing these processes for economic value to provide guidance in selecting the appropriate technologies.
Anaerobic digestion has been around for years, but has the technology changed to make it easier to run a digester, say, on a farm? Because they seem to lose their steam 20, 30 years ago when they were coming out, but now there seems to be a renewed interest.
There is a renewable interest because there is a better attention to some of the environmental issues that digester can address, which is not only reduction of emissions that can generate climate change, but also there is water management, odor reduction, and so forth. But also, I think since then, while the basic engineering is remained largely the same, we have better way to do monitoring. So remote maintenance or remote control is much easier to do than was just a few years ago. And that opens up for developers to do distributed projects and relieving, say, the farmer from the burden of having to monitoring on a daily basis the digester. Digesters are not necessarily very maintenance intensive, but they need to be continuously monitoring. And today, I think this is really on integration technology and internet technologies that allows us to do work that was impossible a few years ago, and that has opened up developers the opportunity to coming up with new business models. So now you see developers that say, going farms and say, we're going to build a digester for you, we'll operate it for you. The only thing you have to do, tend your animals, make sure that they have the manure is produced, and we'll do all the rest for you, and we'll share into the value.
Recently, AURI was involved in a Minnesota Renewable Energy Roundtable that was dedicated to new information on anaerobic digestion. What were some of the takeaways from that event?
There is a lot of interest in the state, and we invited multiple parties, including several developers, and they were all enthusiastic to come because they all see the opportunities that Minnesota offers in terms of development. So just to give you an idea, the American Biogas Council, which is the trade organization, estimates that Minnesota ranks 8 out of 50 states in opportunities for biogas development and production. And just to give you an idea, today we have about 35 industrial and farm-based digesters in the state. We calculate the potential is more than 700. And if we can build 700 digester, we would produce about 50 billion cubic feet of renewable natural gas. To give you an idea what that means the equivalent of 600 million gallons of gasoline equivalent. Gallons of gasoline equivalent is a way to compare energy because everyone is very familiar with a gallon of gasoline. So although we might not use natural gas or biogas as gasoline, gives you an idea of what, how much energy we can produce. This number is even more important when you compare how much energy is produced by our very thriving ethanol industry, which is one of the top in the nation. At that level, our biogas production could be roughly 80% of our ethanol production. So this industry can actually become as big as the ethanol industry is in the state. And this even without accounting for the potentiality of developing some new feedstock like energy crops, which today are not considered in these potential estimates.
If it was to take off like that, is the infrastructure or the natural gas line able to take on that much more? Or would we have to do some rebuilding of the infrastructure?
I think largely the infrastructure exists because we have a very large network of natural gas infrastructure in the state. And so some of our utilities will be looking at replacing the gas that today have that comes from gas field with biogas. So largely our pipe infrastructure will remain the same. The difference will be how, we'll have to make sure that all these digester projects can interconnect. But the large distribution network, so bringing gas to people's home, that is still there and will be we use the same. So that is one of the nice thing about biogas is that largely we can build on our existing infrastructure.
Tell me a little bit about world views on anaerobic digestion. Is it being significantly used anywhere outside of the United States?
It is. And in fact, I would say that the United States, in no little part, because we have been always blessed with abundant and inexpensive source of fossil fuel, we are relatively late to the part, if you want. So today in the US, we have about 2,300 sites for anaerobic digestion, of which 400 are industrial farms. And we consider there is a potential, a conservative estimate, because that doesn't keep in account some of the potential future feedstock like municipal solid waste or energy crops, but we estimate there is a potential for more than 15,000 sites. Just to give you an idea, Germany today, with about a third of the US population, or a bit less than a third, has more than 10,000 operating digesters. So that gives you an idea what the potential is and how much has been used in other countries. And all over the European Union, you'll find similar numbers in countries like France, Italy, Germany, the Netherlands, Spain, and the UK. Now, is also used very much in Asia as well. In Asia, there's been a very different approach, very focused on very small deployment to provide basically alternative to solid fuel. So you're going to find a lot of development in Southeast Asia to use biogas, small scale biogas system, maybe handling food scraps to get people moving away from burning wood or cow dung in their kitchens to a cleaner, especially for domestic air, cleaner biogas. So it's extensively used, a lot of different scales. In fact, I think the US right now is in an enviable situation of being able to take advantage of a lot of technology development that was done abroad. And we see a lot of foreign companies, especially Europeans, trying to now to take advantage of that and bringing and opening offices across the US because they realize the opportunities of this untapped market.
Well, you may have already answered my next question, but I was going to have you comment on your perspective on the future for anaerobic digestion. What does it look like to you?
The future to me looks bright. Natural gas and the ability to have a renewable source of natural gas fits very well within our existing infrastructure. The amount of natural gas we can produce is significant, but is even more significant when you look at local development. And in some community, you could replace completely the use of, especially small rural community, the use of propane, for instance, with the renewable natural gas. And this to me, as they have apart from environmental benefits, could also make this community more self-reliant and less subject to the energy shocks.
We haven't talked a lot about AURI yet, but one of AURI's areas of expertise is renewable energy. So, what is AURI doing in the field of anaerobic digestion and biogas?
URI is positioning itself to be an advisor to anyone that wants to do work in aerobic digestion within the States or in the upper Midwest. And we're focusing specifically in technical and business development advice. On the technical side, if you have a feedstock and you say, can I digest it? How much biogas can I use? We can take that feedstock and do characterization in the lab, from understanding what is in the feedstock, understanding the theoretical potential in biogas, what the digest state, that is the residual, will look like, and how you can use that residuals, for instance, as a fertilizer or soil amendment. And then we can also do some scale-up study and go all the way to do digestion studies up to the couple of thousand gallons digester. So we can start few cc at the bench scale all the way to a couple of thousand gallons. And obviously that will provide a lot of data, technical data, that then can be fed into looking at the business model, what it would cost to build a digester. If you produce so much gas, how you could negotiate a contract with the utilities. And while we're not going to enter necessarily in project development ourselves, we can certainly support the project developers with all this information. If you're a farmer, we can help the farmers, the producer, understanding developers' needs and what value there is for them, for instance, in allowing developers to build a digester on their land.
I think, in other words, stay tuned, more is coming.
Oh, absolutely. And I think we are going to start seeing only the beginning. As I said, this is just using technology we know. But what I strongly believe is that the interest in aerobic digestion and the commercial value that now it has will eventually spur the development of new technologies, which will further advance the use of technology and also make it even a better source, a wider source of energy.
Dr. Luca Zullo, thank you very much for your time today.
Thank you.
And thank you for joining us today and for listening to the Ag Innovation News Podcast. Our guest today has been Dr. Luca Zullo, AURI's Senior Director of Science and Technology. Of course, the Ag Innovation News Podcast is presented by the Agricultural Utilization Research Institute of Minnesota. Thanks to our podcast crew, Eric Evans, AURI Director of Communications, and Lisa Martinez, AURI Communications Coordinator and Editor of this production. To learn more about AURI, visit auri.org.